Good morning, students. Today we discuss about a topic called logic gates. First of all, you should know about what is logic gate. A logic gate is an electronic circuit which accepts one or more input signals and it produces one output signal. Once again, I'll repeat. Logic gate is an electronic circuit which accepts one or more input signals and it produces only one output signal. And it is also called as a switching circuit. Switch means it contains only two conditions. One is off state and another one is on state. In general, we will call it as for on, we will represent it as by 1. For off, we will represent it as by 0. Here, we have to discuss about, already you have learned in the first year about the basic gates. Basic gates is also called as a fundamental gates or a primary gates. We have three basic gates. One is NOT gate and another one is OR gate and the third one is AND gate. Here we can come to know that what is NOT gate. NOT gate means it accepts only one input and it produces only one output. Here already we know that computer will understand only binary language, means binary data. Binary means 2. One is 0 and other one is 1. Within 0 and 1 only we have to give the inputs. Depends upon the input, the computer produces the output. And this is the logic symbol of NOT gate. And the NOT gate, we can come to know that the truth table and we can take it as a variable, means we can identifier also you can call it as that one. Okay. If you give input as 0 and it produces the output is 1. Similarly, if you give input 1 then it produces the output 0. And NOT gate is also called as a inverter. Inverter means it's a complement. That we will call it as a negation. See, if you give 0, then it produces 1. In Kannada, it is an opposite. Now, we will 0 input kotre, nimge output to 1 barutte. Inverse, okay, converse also we will call it as. Now, we will 1 input kotre, output to 0 kodutte. Okay, see, this is the concept of NOT gate. Only one input, one output. And here, the possibilities for two inputs. Okay, see, if you give 0 it produces 1 and if you give 1 and it produces 0. See, the converse, that we will call it as A bar. A is the input and A bar is the output. Okay, see. Similarly, we have one more a basic gate called as OR gate. OR gate. And here we have written symbol for the OR gate, logical OR gate. 2 input OR gate we have written here. 2 input OR gate. By name it as one input A and another input is B. And the result obtained is A plus B. That we have to read it as A or B, where you are going to add logically. Okay. Here, if it is a 2 input and we have suggested a truth table for the 2 input OR gate and you have given the variable A and B. Any variable you can suggest. Okay. You can call it as XY or PQ, RS, anything. Okay. But we have considered it as A is one input and B is one input. And here the possibilities, how many possibilities? Here 2 variable means 2 to the power of 2. 4 possibilities, 4 combination of input you can produce. And you can take it as an example as a permutation and combination. Otherwise, you can take it as a two coins. The possibilities of coin, one coin is either it may be tail or it may be head. Similarly, if you take two coins, then if you toss it, then it may be tail and tail. Tail means here 0 and 0, low. If you give two low input, then it produces low output only. Okay. Rest of the thing, similarly, you can have the possibilities 0 and 1 and 1 and 0 and 1, 1. Okay, here tail and tail, tail and head, head and tail, head, head. See here, you will get the output is high whenever any one of the input signal is high or both the input signal is high. It will produce low output only when both the inputs are 0. This is the truth table. This you have to read it as A or B, means logical addition. 0 plus 0, 0. Means here, if both the input signal is 1, the output is 1. If any one of the input signal is high, output is high. You will get only if both all the inputs are low, then only output is low. See, this is the truth table for the OR gate. That is 2 input OR gate. Okay, OR gate may be a 2 input or 3 input or 4 input. Okay. Similarly, another basic gate is there. Another basic gate called as AND gate. AND gate anta ondide. Okay. See, this is the logic symbol of AND gate. And we have considered as 2 inputs, A and B. The user can give other names also, identifier name. Instead of A and B, you can call it as PQ also, or M and N. In mathematics, you will say no, let A is equal to, B is equal to, like that. Okay. See, here this is a logic symbol for 2 input AND gate, and this is also a basic gate. And the truth table of AND gate, here we have written for 2 inputs A and B, and the output is A and B dot. A dot B means you have to read it as A and B. A and B anta odbeku. Similarly, as earlier I told, the possibilities of 2 inputs, 2 to the power of 2, 4 possibility you will get. Okay. So that is 0, 0, 0, 1, 1, 0, 1, 1. Okay. Means you can give input signal as low and low. Then it produces the output is low only. And it is like a logical multiplication. See, if you give any one of the input is 0 or both the input is 0, then you will get the output is 0 only. If all the inputs, now we have considered this is for only 2 inputs. Okay, if both the inputs are high, then only it produces output is high. It gives an output signal 1. When all inputs are high. ಎಲ್ಲ ಇನ್ಪುಟ್ಸು ಇಲ್ಲಿ ಹೈ ಇರಬೇಕು, ಆವಾಗ ಮಾತ್ರ ಯು ವಿಲ್ ಗೆಟ್ ದ ರಿಸಲ್ಟ್ ಹೈ. ಯಾವುದಾದ್ರೂ ಒಂದು ಇನ್ಪುಟ್ಟು 0 ಇತ್ತು ಅಂದರೆ ಇಲ್ಲಿ ಔಟ್ಪುಟ್ಟು 0 ಇರುತ್ತೆ. ಓಕೆ, ಇಫ್ ಬೋತ್ ಆಲ್ ದ ಇನ್ಪುಟ್ಸ್ ಆರ್ 0, ದೆನ್ ಓನ್ಲಿ ಯು ವಿಲ್ ಗೆಟ್ ಅ 0 ಇನ್ಪುಟ್. ಓಕೆ, ಆ್ಯಂಡ್ ದಿಸ್ ಈಸ್ what we have written is a logic symbols of all simple gates, logic gates, NOT gate, OR gate and AND gate. And so these are all we have already studied in the first year. Okay, next here universal gates. Why NOR and NAND gates are called universal gates? Because using NOR and NAND gate we can implement all basic gates, means primary gates, fundamental gates such as NOT gate, OR gate and AND gate. Let us discuss more about universal gate in the next class. ಮುಂದಿನ ತರಗತಿಯಲ್ಲಿ ಯೂನಿವರ್ಸಲ್ ಗೇಟ್ಸ್, ನಾರ್ ಗೇಟ್ ಅಂದ್ರೇನು, ನ್ಯಾಂಡ್ ಗೇಟ್ ಅಂದ್ರೇನು ನಾವು ಮುಂದಿನ ತರಗತಿಯಲ್ಲಿ ತಿಳ್ಕೊಳ್ಳೋಣ. ಈ ತರಗತಿಯಲ್ಲಿ ನೀವು ನಾಟ್ ಗೇಟ್ ಬಗ್ಗೆ ತಿಳ್ಕೊಂಡ್ರಿ, ಆರ್ ಗೇಟ್ ಬಗ್ಗೆ ತಿಳ್ಕೊಂಡ್ರಿ, ಮತ್ತು ಆ್ಯಂಡ್ ಗೇಟ್ ಬಗ್ಗೆ ತಿಳ್ಕೊಂಡ್ರಿ. ಓಕೆ, ಇವನ್ನ ಪ್ರೈಮರಿ ಗೇಟ್ಸ್ ಅಂತ ಕರೀತಾರೆ. ಆ್ಯಂಡ್ ಇನ್ ದ ಎಕ್ಸಾಮಿನೇಷನ್ they'll ask, write a logic symbol of NOT gate. You have to write this. Then they'll ask, write a logic symbol of OR gate. OR gate symbol ಕೇಳಿದ್ರೆ OR gate symbol ಬರೀಬೇಕು. 2 input. Particularly they'll ask, write a logic symbol of 2 input OR gate. Or just if they ask only OR gate, then also you can write. ಅವಾಗ ಕೂಡ ನೀವು ಬರೀಬೋದು. Similarly, here this is a 2 input AND gate. And through these gates only, all our next topic we are going to discuss, that Boolean algebra. Okay, everything falls in the state, either it states in true state or false state. The possibility is only one. Irrespective of inputs, it produces only one output. This is the concept of logic gates. Thank you, students. We will continue in the next class. Thank you very much.